everyone, Chang here and welcome to my channel. This is a skill building video series where we pick a specific skill and we practice it so that the next time when we see a problem that actually requires that skill, we can solve it with ease. Let's begin. So for today's video, we're going to focus on solving linear equation with variables on both sides. So what does that mean? Well, normally when we solve a linear equation, variables on one side, all we have to do is actually just clear it all out, have the variable equals whatever, and then that's our answer. But this time it's a little caveat, extra practice, but now we have variables on both sides of the equation sign. Now, in order to solve that, the first thing you got to do is move all the variable on one side, right? We have them on both, we're not sure what to do. Once we move them all on one side, we can now solve it like a regular linear equation. And that involves combining like terms, attempting to isolate the variables afterwards into variable equals something. And then you have your final answer. Now, here's the thing though. When you have variables on both sides, there's actually two very odd situations that could potentially happen. One is that everything cancels out. Everything, all the numbers, all the variable cancel out once you try moving it in and out from one side to the other. And that means a specific solution. The second one is that only the variable cancels out. And that also means another specific solution. And we're going to talk about that. So let's begin. Alright, so this is our first problem. We have x minus 6 equals negative 7x plus 8. Once again, we have variable here and a variable here. What we're going to do is we're going to move all the variables on one side first. And we can do that just by normally when we move things around by canceling one and another. This one's a negative 7x. So in order to cancel it, what we're going to do is we're going to do the opposite. So we're just going to add 7x here. What we do to one side, we must always do to the other. So we're going to add 7x here. Notice that I just line it up specifically under the x because that's where we're going to add it. Now, this one's x, technically 1x, right? So 1x plus 7x is 8x. We have the minus 6, which we haven't done anything, and then this one is gone, right? This is a 0, and we have an 8 right here. Now we have a regular linear equation which we can now solve. So for this one, we're going to do the opposite. We want to isolate x and everything else goes away. So we're going to plus 6 plus 6. This goes away. 8 plus 6 is 14. Now we have 8x over here. 8x equals 14. Now what we're going to do is basically we're just going to get rid of the 8. We're going to divide by 8 because it's multiplication. Do the opposite. Divide by 8. Divide by 8. So what we have here is basically x equals 14 over 8. And of course, if you want to simplify it, it's just going to be 7 over 4. So this would be our answer for this problem. So for the second problem, we have 2x minus 4 equals 2x plus 10. Now we're just going to follow the regular suggestion. We're going to move all the variable into one side. It can be here or here, so that's the thing. You can move it whichever side you want, you're more comfortable with. I'm just used to moving it here, so that's what I'm going to do. Right? I'm going to subtract 2x here because this is a positive, so I'm going to do the opposite, negative. Right? So subtract 2x here, and then well, we have 2x minus 2x is 0. Okay, this goes away. Now we have minus 4 equals 10. Now here's where it gets a little weird. Notice this. By moving this 2x to the other side, by subtracting it, right? We do it on both sides. All of a sudden, it cancels out and we don't have an x anymore. So how do we solve for something where the x just disappears? Well, this is a case where basically you technically have no solution. This original statement is false no matter what. And ignoring all the red marking, I want you guys to pay careful attention to this problem. Notice this, 2x minus 4 equals 2x plus 10. Now, they're saying that 2x minus 4 is the same thing as 2x plus 10. Well, x could be any number, right? It might be some number we don't know, but whatever the number x is, it has to be the same on both sides. Well, how can it be that 2x minus 4, the same 2x, but one of them is going to be minus 4, the other one's plus 10 is the same, I guess you could say, expression. It's not, right? 2x minus 4 can never be 2x plus 10. So hence, this kind of situation happens. So when you have something like this, where the variable just cancel out, it just means there's no solution. This original statement is not true in any way, shape, or form. All right, so for the third problem, we have this one. 7x plus 10 equals 3x plus 5 plus 4x plus 5. Well, here we have 3x and 4x. Let's just combine like terms. All right, everything's going to still be the same except for 3x plus 4x is now 7x plus 5 plus 5. There we go. Okay, and then here we have 7x plus 10. And then before anything, once again, we have variable on both sides. Let's just follow our suggestions. Move all the variable on one side and everything else we leave alone for now. We have 7x, subtract 7x. Okay, well, this one all disappears again, right? Because this one cancels. 7x minus 7x is, well, 0. But, I mean, does this mean that this has no solution too? Not exactly. Here's what I want you guys to notice here. We have a plus 10 equals, and 5 is 10. There it is. So if we wanted to, we can subtract 10 on both sides, and all of a sudden everything cancels out. You have 0 equals 0, which is true, or 10 equals 10. It doesn't matter. So why does this happen? This is the second odd situation where everything basically cancels out. Now, here's what I want you guys to notice. I purposely wrote this problem so it's not nearly as obvious, but at this part, we have 7x plus 10 equals 7x plus 5 plus 5. This right here is technically 10. So 7x plus 10 equals 7x plus 10. Yes, of course it is, right? 7x plus 10. This is the same 7x. This is a 10, and 10 is the same no matter what. So this expression right here, exactly the same as this expression right here. So it doesn't matter what x is, this statement is always going to be true. So notice the subtle difference. The previous problem I showed you, only the variable cancels out. Everything else you can start manipulating, do whatever you want, but it doesn't cancel out. This one, not only does the variable cancel out, you can actually cancel out all the numbers as well, right? And it just becomes 0 equals 0. Or if you wanted a number equals a number, in this case it would have been 10 equals 10. This means that all solutions work. So remember, the other one was no solution. This one, x could be anything and this would work. Alright, so for the remainder of the video, I'm going to refrain from some explanation. Hopefully you guys can follow along. Now, the one thing I want you guys to pay attention to is, remember, the key difference between something that has no solution and something that has basically all solution. Every solution works, right? So, let's begin. Thank you for watching this video on linear equation with variables on both sides. See you in the next video.